The fact that probability is such an intuitive part of our day-to-day lives can be both a blessing and a curse for us. On the one hand, what this means is that we already have a lot of notions about what probability is, and when we start to build this all out formally, this is going to really help us to stay grounded in what probabilities represent in the real world. On the other hand, any time that our intuitions are going to let us down or lead us astray, this can make dealing with the probability concepts more difficult. And so oftentimes we're going to be leaning on our intuitions from probability around us in order to better understand topics. Other times we're going to have to be fighting against those intuitions. So some actions lead to uncertain outcomes. This can be sort of as broad as we want to be thinking about it. When we're thinking about those actions leading to uncertain outcomes, there's typically some set of outcomes that might occur. When we're thinking about those sets of outcomes, some of them are going to be of more interest to us than others. And so, for instance, thinking about the weather tomorrow, right? Tomorrow comes along, there's going to be a set of uncertain outcomes. Is it going to rain? Is it going to be sunny? Is it going to snow? And so forth. And certain of those are going to be more interesting to us than others. We're not going to be super interested in thinking about does the sun rise or not, because we pretty much know that it's going to rise, right? There's not going to be a lot of us discussing, well, what's the probability the sun actually rises tomorrow? On the other hand, thinking about the probability that it rains tomorrow is going to be of particular interest to us. And so when we start to think about the world around us and think about all the ways that chance is playing a part in the world around us, we're going to want to start to highlight certain outcomes that we might care more about as compared to other outcomes. Okay? Now, anytime we're thinking about there being a random action or an action that causes some random outcome, we can define this to be what we call a statistical experiment. So a statistical experiment is any process that generates an uncertain outcome. So this is as broad as we can be. If something is occurring and we don't know what the outcome is going to be, we can think about that as a statistical experiment. Now, once we have a statistical experiment, we can define the sample space, and the sample space is just the set of all possible outcomes from that experiment. So if we flip a coin, that's a statistical experiment because we don't know what it's going to show. And then the sample space is going to be the set of possible outcomes. So we can either see a heads or we can see a tails. Okay? Typically, in terms of notation, we define the sample space to be this S here. Okay? And the S is going to be representing our sample space, right? And we normally write it as a script S. And then what we're going to do is we're going to write it out in this mathematical set notation here. So we put two curly brackets, and then inside of those curly brackets, we're going to be putting all of the different elements from the sample space here. Now, we can also define an event. So an event is going to be any subset of the sample space, and usually the event is going to be something that we care about. In terms of the notation, we're typically going to use standard letters, perhaps with subscripts. So we might write E1, E2, E3 to be different events. And then we're going to bring in this little symbol here, the containment symbol. And what this means is that E1 is going to be a subset of S. And so essentially, right, S is going to have any number of elements inside of it. We're going to take out some of those elements and we're going to write a set that is made up of those different elements, and that's going to be called E1. And so then we say E1 is a subset of S, meaning that everything that's inside of E1 also exists inside of S. There can be things inside of S that are not in E1, but everything in E1 needs to exist within S. We will define two different types of events. So a simple event is going to be an event that contains only one single item. An event that contains more than one item is called a compound event. Right? So we have a statistical experiment is something that occurs where the outcome is not going to be certain. The sample space is the set of all possible outcomes from the statistical experiment. And then an event is going to be a subset of our sample space, and it's going to refer to things that we typically care about. Events can be simple if they only consist of one single outcome, or they can be compound if they consist of two or more different outcomes. So let's look at some examples to try to solidify all of this jargon here. So if we think about the experiment as flipping a coin one time, we can ask ourselves, well, what is the sample space? What are some events here? Okay. The sample space is going to be the set that contains heads and tails. And anytime that we want to express sample spaces, any way that we can frame this where individuals are going to know what we're talking about is going to work, right? So we have our set here, and then we put in an H for heads and a T for tails. If you wrote out heads and tails both, that's going to work fine. If you wrote that the sample space was going to be a 0 or a 1, and then you just defined that a 0 meant head and a 1 meant tail, that's also going to be fine. Okay, and so how can we define events for this? Well, events are going to be sets that are made up of either heads, tails, or potentially both, right? And so if we take E1 to be the event that is just a head, right, then we would say that E1 occurs if we flip a head. E2 is the event that we have just a tail, so if a tail occurs, then the event E2 occurs. Now with E3, we have something a little bit weirder going on, right? We've taken heads and tails both, okay? And so this is still going to be fine because it's made up of only things from our sample space, but we're going to say that E3 occurs if either a head or a tail occur, right? So in other words, E3 is always going to occur. In this situation here, we can say that E1 and E2 are both simple events, and E3 is going to be a compound event, right? Because E1 and E2 both have one single outcome, E3 has multiple outcomes. Now, what if we wanted to roll a 6-sided die? Okay, so here, right, the sample space or the statistical experiment is rolling the die. The outcome is uncertain. The sample space is the set of all possible outcomes. And so here, that's going to be the numbers 1 through 6, right? Because we're going to observe something. It's 1 through 6. We can now think of any number of different events that might occur here, right? So to write down a few, we have the first one being just that we roll a 1, right? So if you roll a 1, then E1 occurs. E2 is the event that a 2, a 4, or a 6 have occurred. So in other words, E2 is the event that we rolled an even number, right? So if we think about E2, this is fine because we have our 2, 4, and our 6, and so it's a subset, right? E1 here is a simple event. E2 is a compound event. E3, 1, 2, 3, 4, or 5, right? And so in other words, this is the event that we roll anything but a 6, or a number that is less than 6, right? You can think about how you want to phrase this. But if we roll the die and we roll a number less than 6, then we say that E3 has occurred. Playing 2 games of soccer in a row. Okay? And so here, the experiment is going to be our soccer game, and we're going to be thinking specifically about the outcomes in terms of whether you win, you lose, or you have a draw. And so the sample space is going to be these, all of the combinations of 2 different wins and losses or draws, right? And so we can have a win and a win. We could have a win and then a loss, a win and a draw, loss and a win, loss and a loss, loss and a draw, or a draw and a win, a draw and a loss, a draw and a draw, right? That's all of the different possible outcomes that we can have from playing 2 games of soccer in a row. And then to form events, right, we can take out any number of the subsets of these. And so E1 is the event that we lose both games, right? A loss and a loss. E2 is going to be the event that we either lose both games, win both games, or draw both games. And so in words, we could say, well, E2 is the event that we get the same outcome on both games, right? We don't know if that's a loss, a win, or a draw, but it's the same on both of them. E3 is a win and a win a loss, or a win and a draw. And so that's going to be the event that we win the first game, right? Because anytime that we win the first game, E3 has occurred. Anytime we don't win the first game, which would be all of these other different events down here, then E3 is not occurring. Okay, and so we can start to think, well, in the real world, we might want to be asking ourselves, what is the probability that we lose both games? What is the probability that the event, that our outcome is the same on both games? Or what's the probability that we win the first game? And so all of these are ultimately going to need to be framed in terms of the events here. And so with our soccer playing example, we would have that E1 is a simple event and E2 and E3 are both compound events. An example here, you draw a marble from a bag that contains 5 red, 10 blue, and 20 green marbles. And what's the sample space here? Now, an important rule for our sample space and for writing down any sets in a mathematical context is that we never repeat items in a set. Okay, and so the sample space here is actually only going to be 3 elements long, and it's going to consist of just the events that might occur if we perform this. And specifically, we're either going to see a red, or we're going to see a blue, or we're going to see a green, right? So the sample space is just red, blue, and green. Different events that we might see, Well, maybe we get a red marble, maybe we get a blue marble, or maybe we get one of a red, blue, or green marble. Right? You could also think about a red and a blue, for instance. So E1 and E2 are both simple events. E3 is a compound event. Probabilities are ultimately going to be assigned to events. These events are based on the underlying sample space, and the sample space comes out of a statistical experiment. And so ultimately what we're trying to do with this is we're trying to take these notions that we have of probability, where things in the real world occur by chance, and we're trying to add some mathematical language to it. So these terms are going to get thrown around a whole lot while you're learning probability. And this jargon really is just making something that we intuitively understand a little bit more mathematically formal.